So Pandit, you can start from the basics of SDR, and then we can switch to GND radio.
Sure, sure, sir, sure, sir.
Uh,
The slides are visible, sir.
yes, Pandit.
Sir, basically, I was expecting an interactive session so that I can also understand like how far you know, and in the same way, like how I can modify my way of approaching you based upon the input whatever you are giving. So basically, hope you are aware like what is SDR. So SDR is nothing but you can see it from the slide also, no issues. SDR is nothing but a technology wherein software modules run on a generic hardware platform. The platform may be either DSP core or FPGA or GPU or a processor, anything it defines. So it is nothing but like a platform where I can do my radio functionality with the help of a GPU or a DSP or an FPGA, where I can able to reprogram the device and run my application. So it is a combination of both hardware and software. So initially we'll be talking about the hardware and then basic introduction, what are the different hardwares are there. Then we'll go about the software, what are the different softwares are there. Then we'll concentrate a little bit on GNA radio, and this workshop is basically for a kickstart on GNA radio, how to use it, what are the parameters are there. So if you're, what kind of error basically you'll be getting when you're kicking start with this GNA radio and how to correct it. Uh, could you please explain like what is the traditional radio communication will look like? Any response, or else I can go ahead. So I'll just go ahead actually. See, why we are going for SDR? It's simple example. So I think you know the spectrum. It's from DC to, it's going on a millimeter wave, it's going on. So if I'm having a device for a particular application, example like I need to use it for a simple example like I'm using your mobile phone as a 2G phone. If you are migrating to 3G, then you are going for another 3G phone. If I'm going migrating to 4G, I'm going for a 4G phone. If I'm migrating to 5G, then I am going for a 5G phone. So what is happening like for a different application, I need to use like a different hardware to test and develop something else. So what will happen? No, like the usage of hardware will be more. In case of this SDR, I'll be having a single device where it can be used for like a 2G, 3G, 4G, 5G testbed kind of application. Any other application, it's a simple example. Like, and one more thing is like why we are going for like SDR is like, see, if I'm going for like, a traditional way of radio communication for a particular application, I need to do the analog circuitry part, where we'll be facing some problems while designing the circuit and doing rigor works and other stuffs actually. And if you want to upgrade it, then it will be very difficult task for us to upgrade it. To avoid that, to make it simple, reusable. It's not simple; it's complex actually. To make it reusable, configuration is faster, and getting an output in a lesser amount of time, we are going for an software defined radio domain. So these are the difference. Design flexibility in SDR it is there, in conventional it is there, but it is complicated. Reliability, yes, in conventional it is not there. Design time flow, yeah, is faster, since it is we are defining the radio functionality with the help of a software, it will be easy. If I'm going for a circuit base, it will be harder. So design flow is better in SDR. In conventional radio, it is also better, but it will take a speed time. Upgradability, yeah, in SDR you can do it, but in conventional you need to design an upgradability, like you need to design a own circuit one more time instead of going for a same device to do the stuff. So SDR is nothing but, see, for your understanding, I'm going to define a radio functionality with help of a software. So to define the radio functionality, I'll be having a hardware and a software. So that is a small brief explanation. So I'm going to define a radio function, that is, in case of your like layer wise, I'm going to define the physical layer of my communication. So as per the history, everything starts from the US military. So software defined radio was coined in 1984, 1990. These are the history and geography. You can browse it through internet and you can get the information. So this is the basic setup of your SDR hardware architecture. So we'll be having a RF data board, and I'll be having a host connection and a processing unit. So this RF data card is meant for like converting from like your ADC to DAC. Those kind of conversion are for your understanding from RF to IF and IF to RF. And your FPGA will act as a processing unit to push the information to your PC, that is CPU. In the CPU, you'll be having the software. So this is the software part, and this is the hardware part. The whole structure is SDR architecture. So you'll be using RF front end for baseband conversion, and the host, the FPGA and CPU is meant for like multi processing subsystem. So it will process the information signal, whatever you are giving, it will be processed there. This RF front end is only meant for RF to IF conversion and IF to RF conversion while transmitting and receiving. So these are the advantages. It's open source, so implementation wise it will be easy. You can upgrade the system faster. There are disadvantages also is there. The price of the SDR hardware will be too costly when compared to the normal traditional radio. It will be too costly, since it is having an FPGA and RF option is also inbuilt. So it will be too costly when compared to the traditional radio. If you want, because for learning purpose, if you want to do a test bed kind of thing, SDR will be the better platform for you to move further. So application wise, there are wide range of application we can use this SDRs. You can use it for radar, sat communication, cellular base station, wireless deadbed. This wireless deadbed is an image from an university called Rutgers University in US, and it is being maintained by 5 Indian professors. The name of the lab is Orbit Lab. Up to 2012, it was active. After that, there is no updation from them. There are around 200 years of fees in rooftop for testing various wireless communication. This is an education institute, and in satellite communication also they are using this device. Radar. So any application where we can write your algorithm, can do it with this. And this is a 4G LTE stack that has been built by Amerisoft. It is a paid version tool. You can purchase this tool completely and put it in a base station. It will work perfectly. If you are going for an open source, then it's OpenR interface is there, or SRSLT is there. Again, one kind of application is ADSB, where in Air Force, Indian Air Force, right now they are working on it. Actually, they are trying to generate their own ADSB signal so that our flights won't get detect with the enemy's radar. In those kind of application, they are using the ETS USRPs only for that application. And for satellite communication, this is an example. Like I think it is in 2000. 11 or 10, I think so. They are able to communicate with the satellite that has launched 36 years before from NASA to check the climate changes in North America. They are unable to pull it down, but they are able to make a communication between the satellite and this USRP device. So why I'm explaining this one is, this is the capability of the device. The only thing is, they have used the world largest antenna. This is the antenna. I think you can see the trucks here. So it is a, I think they told like it is a size of a five football stadium or something they told. So they use this tool to communicate with the satellite, and he is the ETS guy, and these are the professors from European Union. It's a collaborative project from ETS and European Union. So they are able to make a communication with the satellite. They are able to ping it, but they are unable to pull it down since it is lying as a junk for the past 36 years. There is no enough power to pull it down. See, when you are going for like SDR, as I mentioned, it is a combination of software and hardware. Basically, like if I'm going for a software tool, There are two varieties are there. One is commercial and one more is open source. If you're going for a commercial, NA lab use there. MATLAB Simulink you can use it. Scilab also you can use it. Scilab will be coming under open source. See, these are the major commercial software that are available. If you are going for an open source, basically we'll be looking for like Gnuradio or Gnuradio is a major one. Scilab, whoever is interested, you can go for like SEARI. This is the initial version of software they have used for programming this tool. Right now, it is not there. It is under Indian, sorry, US military when it is initiated initially. Or else, if you are good in Python, then you can able to write your application in Python using a tool called Altair Compose, where it is quite similar to MATLAB. It's a open source. I think it is an open source. I think so. You can, if you are good in Python, you can write your Python application there directly, and you can run your application from there. So no need to use LabVIEW or MATLAB or Gnuradio. You can use that tool also. There are number of tools are there. So whichever is feasible, I can go for it. But as per this presentation, we'll be concentrating on Gnuradio. And on the hardware side, there are many vendors are there providing SDR hardware. Basically, like NI is one of the pioneer, and ETS is the part of NI. So in ETS, they'll be selling USRPs in the range of like from bus series to network series to X series to embedded series. So what is the difference between NI USRP and ETS USRP is like this is for your basic information. Any USRPs are defined with a software tool. It will work with LabVIEW. So it is left to us to configure the NA USRP to be interface with MATLAB or Gnuradio. Then you need to erase the content. If your warranty is void, you can use it. In case of VTES USRPs, it's not defined to a particular software. So we can interface with MATLAB, we can interface with LabVIEW, we can interface with GNU radio also. Same device can be interfaced. The only thing is like each and every time when I'm interfacing with different software domain, I need to erase the firmware and do it. That is the only thing you need to do it. In case of VTES USRP, in our campus we have X series and bus series, if I'm not wrong. Those two devices are there. X series is the highly advanced version of USRP. Bus series is the basic version. Network series is the intermediate version. Embedded series is standalone. So if you are looking for a standalone base application, you can go for an embedded series. Right now, in ETS they are released like network series itself. N300 series are there. It's a like it will be a dual functionality. It will act as a standalone as well as you can interface with your PC. In case of X series, bus series, and network series, like N200 series, you need to have a PC to program the device. In case of N300, it will act as a standalone as well as it can be interfaced with the PC for programming. Embedded series is standalone. Anyway, you need a PC for programming these devices. Once it is programmed, I can make it as a standalone device. In case of NAUSRPs, there are different series of that: 2920, 2921, 2922, 2930, 2932. So these are different varieties are there. So depending upon our application and budget, you can select any of the devices. Apart from this NI range of USRPs, there are other USRPs also available locally in the market. You can go for Blade RF, Hack RF. There is one more a company called they are into GPU plus SDR. I think so. The company name is Digital Signal Processing or something. Then I forgot the name. Once I get it, I'll just show you the link through the website. So they are having like your Intel Jetson Nano or Jetson Xavier AXI with a Zinc FPGA along with ARM Cortex and then RF front end. So if you're looking for like I need a standalone and I need to have a more GPU to process the information to get a proper output, you can go for that. If you're looking for a local, sorry, not local, lower version, you can have like RTL SDRs. Those are receivers that can be used for any receiving based application. So in which way you can select no ETS USRPs. If you're not particular about the software tool, you can go for ETS. NI, if you're working for LabVIEW, then it is better to go with NI. Nuan, like it is in the that is Blade RF, it is intermediate. So if you're comfortable with MATLAB and Gnuradio, you can go for that. HackRF, it's one. The thing is like it can be interfaced with Gnuradio as well as MATLAB. The only issue is like your NUA and NAUSRPs are full duplex. In case of HackRF, it is half duplex. Either you can use it as a transmit or receive. In case of other SDRs, hardware, whatever we have explained, it is full duplex. Do you have any doubts, sir?
Could you please explain that standalone one once more?
Which stands, sir?
The standalone one that you said that.
So it's embedded series, sir. So it is
What?
basic. I'll explain, sir. In the next slide, I'll explain to you. Next slide will be on
Okay.
SDRs only, hardware only.
Okay. Okay. Thanks.
Since we are the distributors for e-test research, we'll be concentrating only on the e-test USRPs. USRP, Universal Software Radio Peripheral, and this device is manufactured by e-test research, and it is like funded or the founder of this company is Matt Eates. He is the one who initiated the concept of GNU Radio as well as this one, because he is one of the member of the core member of GNU Radio when it is initiated long back. Basically, most of the ETS USRPs are directly compatible with GNU Radio, and see in your when you see the architecture itself in the second or third slide, it is having a FPGA, ADC, DAC, host processor interface, and everything is there in case of your hardware setup. In the host processor interface, define the name of the device. So if I'm using an USB, it is called bus series. If I'm using an Ethernet, it is called network series. If I'm using an Ethernet with a higher like bandwidth, like 10 gigabyte, then it is called X series. If I'm using an Ethernet base with standalone and a combination of standalone as well as interface, then it is called N300 series. And basically, the main part of this USRP is the UHD, USRP hardware drive. So this hardware drive is the main source that is interfacing our software with our hardware. So when I was conveying to you it can be interfaced with MATLAB, LabVIEW. So the UHD driver will be erased, and the firmware of the USRP also will be erased whenever whenever I'm migrating from different software tools. So this is a small presentation on what are the different type of USRPs are there. So basically, the basic version is bus series. The interface is through USB. It will work from 70 megahertz to 6 gigahertz. The RF front end is inbuilt. The chipset either it will be 89361 or 89371. So either one of the chipset will be there. In bus series, there are four varieties are there: B200, B210, B205, and B205 Mini I. So these B200 and B210 are the bigger one, where we'll be having a Spartan 6 FPGA. Everything is having Spartan 6 FPGA only. The only difference is like in B200 the logic element will be less. In B210 it will be more. B205 Mini and 200 Mini is nothing but your credit card size SDR. If you are having an application where the SDR should be of smaller size, then you can go for the Mini, and it is industrial grade. Since Sir asked the embedded series, so embedded series is nothing but a bus series, that USRP B200 or B210 with a SBC inside. So it will be a size of our mobile phone. So standalone device. So it is based on Zinc FPGA, and it also works from 70 megahertz to 6 gigahertz. It will be having an internal GPS DO also inbuilt. It will be having two channels, two transmit and two receive. Everything remains the same. So and like the only thing with this embedded series is like this embedded series doesn't have an UI, graphical user interface is not there. So if I want to program the device, then I need to have a PC. Then I need to debug through Ethernet or USB to write your application. Once the application is written, then you can make it as a startup program and you can write your application. Sir, whether it is clear with the embedded series, or I need more explanation, sir.
No, it's okay.
In case of network series, the basic version is called N200 series. These N200 series doesn't have an RF front end. So basically, you will be having N200 in our campus. So it doesn't have an RF front end inbuilt. So RF front end need to be purchased depending upon your application. So in N200 series, we'll be having Spartan 3 FPGA. There are two varieties of that, N200 and N210. The basic difference is the logic element size. And basically, like if I'm going for like this N200 series and bus series, I can't access the FPGA. So the FPGA here, it is very small, so we can't access the FPGA. If you want to access the FPGA and do some kind of programming over the FPGA, then you need to use for X series. You need to go for X series, embedded series, and N300 series. The concept is called RFNOC. It is available in the internet. You can browse it because our workshop is not considered an RFNOC. You can check it in the internet. So RFNOC is basically is nothing but I'll be writing a part of my application inside the FPGA so that the signal processing will be happening. Some part of the signal processing will be happening in my FPGA and the remaining will be happening in my PC. So basically, if you are not using RF NOC, it is just like most of the signal processing is happening only in my PC. This device is just acting as an RF to IF converter. So what is the difference between network series and X series? Is like in network series, N200 series. If I'm conveying network series, it's N200 and N210, not the N300 series, because it's an advanced version. We are not going to concentrate much on it. N200 and N210. What is the difference between N200 and N210, X300 and X310? Is like your single X310 is equivalent to two network series. So it is having two channels. In case of N200 and N210, it is a single channel. It is a dual channel. So two RF dot record can be placed and it can work simultaneously with the two RF dot records. And the other specialty of this X series is like application wise, I'm just differentiating the device. If you are going for, if you are going to test the basic modulation, and if you are going to test the basic test bed apart from MIMO and cognitive radio, then you can go for bus series. All the application will work with bus series apart from MIMO and cognitive radio. I want to go for MIMO and cognitive radio with minimum bandwidth, then you can go for network series. If I want to do all the application with better bandwidth, then I need to go for X series. X series is having a bandwidth of 40 MHz as well as 160 MHz. That depends on the RF front end, whatever we are interfacing with it. And in case of this RF data cards are meant for like your network series and X series. There are different varieties of RF data cards are there. Basically, four varieties: uh, WBX, SBX, CBX, and UBX. So depending upon my application, I can select any one of the RF data card. So your WBX will work from 50 MHz to 2.1 GHz. SBX will work from 400 MHz to 4.4 GHz. CBX will work from 1.2 GHz to 6 GHz. UBX will work from 10 MHz to 6 GHz. These informations are already available online. Just for your information, I'm just conveying it to you. You can browse it in the internet and you can get the information. And see, if you're basically specifically going for some kind of application, like I'm going to go for MIMO, cognitive radio kind of application where you need a phase synchronization with the signal, then you need to go for SBX and UBX. These are the two RF data cards that are having a phase coherency inbuilt. And the newly launched RF data card is called Twin RX, that is compatible only with the X series, that is available in your campus. So this Twin RX is meant for like only a receiver. So if you are having an application like radar based application completely, then you can go for a Twin RX. So basically, ETS USRPs are differentiated in four varieties depending upon the interface. If it is USB bus series, if it is standalone embedded series, if it is Ethernet with lower bandwidth, it is network series. If it is Ethernet with higher bandwidth, it is called X series.
Hello. For the network series, the bandwidth will be for X series. It's about 40 megahertz. You said, right?
40 and 120 megahertz. For network series, sir, everything is theoretical.
Yeah, it's a theoretical, but on testing we will get around, if it is 40, then we can test up to 20 or 10.
20, yeah, the same case for your network series also.
For network series, how much the bandwidth is?
Sure, it's 40 megahertz only.
Okay, it's 40. Okay.
Practically, we can able to achieve 20 to 25. That depends on the like our PC processing also.
Yeah, that depends on the how much clock and everything.
Everything. So if I'm using a dual core machine, it will be very difficult for me to make it.
Yeah, sure. Okay.
So, any queries, sir?
Sir, regarding the software part, so is there any advantage of GNU radio over MATLAB?
Ma'am, the advantage and disadvantage are both are there. See, the first thing is like if you're using a MATLAB, you need to pay and make it. In case of GNU radio, it's free. First.
Okay.
And
Yes.
the difficult part is like, see, if you can call to MathWorks and get a code done if you're paying. In case of GNE Radio, it is not like that. It is our headache to design our application. See, the thing is like the learning will be more in MATLAB also. It will be there. That depends on the person who is going to use it. So if he is comfortable with MATLAB, you can go with MATLAB. If I'm comfortable with open source GNE Radio, you can go for GNE Radio. And for your kind information, GNE Radio is meant for Kickstart only,
Okay.
for the SDR. Once the kickstart is done, if you are good in C++, you can write your application in C++ directly. GNRD is not needed. See, GNRD is meant for like, see, basically if I'm going to work on something, if I'm having an UI and I can able to change something else, it will be like more interactive to me, so that I'll go through the like application faster, or algorithm development faster. If it is everything is not in UI, no, it will be very difficult for me to debug also.
Yes. Yes.
So GNRD is meant for kickstart only. And this GNA radio is not only for this SDR. So this is for signal processing. See, for example, if you're taking a class to a BTech students, if you want to like explain to them like what are the different windowings are there, if I'm using this window, what is happening, how Nyquist criteria is achieved, those kind of things can be simulated with the help of GNA radio. GNA radio and MATLAB both are same only.
Hmm.
The only difference is like this is open source, that is paid, and that is MATLAB is it's on the whole, like you can use it for embedded based application, you can use it for VLSI based application, you can use it for communication based application. In case of GNRE, it's only meant for signal processing.
Okay. Right. Got it. Thank you.
Sir, any other queries, sir? Sir, any other query?
I think there's no query. We can proceed with next.
Yes, yes. Hope everyone install GNA radio, sir.
Hello. Yes, I have installed JNE Radio just before this class. So if you can present the interface, then I'm able to relate.
Sir, you're using which operating system, sir? Windows or
Windows.
then just in the start, just write type GNA radio, and
Yeah, it's open. Should I share my screen?
yeah, you can
Should I-
share. You can share. I'll just
Yeah,
close my.
I'm sharing.
Just a second.
So I'm getting
Yeah.
this interface.
Yeah, it's fine, sir. Which version, sir? Actually, just for your kind information, right now the newer version is around 3.9.
Okay.
GNA radio. So if you're having a newer version, there are multiple options they are providing. I think you can create your own Python block also with the here itself. No need to go for OOT module to create a block and do something for basic application. You can use in 3.8. You can there is an Python block already available. You can double click and do it. The application note is already available in our website. So I'll just show you the application note, so that you can go ahead and do it.
So
This is
for
for
today's
basic.
session, is this enough? For today's session only, then we will install the higher version.
No. So it's not that. It's an advanced one.
Okay.
So see, for just for your information,
3.7, it's written. Okay.
see 3.7. It's a older version. If you're having
Yes.
greater than 3.8 or 3.9,
9.
then you may able to have the like the creation of blocks module also is there inbuilt.
Yeah, I got
And
it.
and one more thing for your kind information, so you'll be downloading some grc file. So whatever application they are creating in GN radio, it is called grc file .grc extension is. So for example, like you'll be downloading some content from internet, and what will happen, no, this is for your basic understanding before kickstart with GN radio. Something will be missing, because for different version, what these people are doing, no, they are removing them some blocks, and they are adding some other blocks. So in 3.7, if you are downloading a 3.3 version content, the block will be missing.
Yes, yes, yes. For upgradation, they used to do this.
Yeah, they used to remove it actually. That is the issue with this GNA radio.
Yeah,
Shall I start? Shall we start with GNA radio, sir?
yeah, sure.
Yes, yes. Please. Let me share the content. Sir, as I told initially, GNA radio is not a tool particularly meant for interfacing with your USRP. It's one of the software tool available here. And GNA radio is it's completely meant for signal processing related application. So whatever application you are having in your mind, if you want to create an algorithm and check it, you can use this device. And it won't provide a foolproof kind of mm, how to convey like results. So this is for a simulation, so whatever is feasible from it, it will provide. And this is a community formed in the year 2005, I think so, based upon the theory. Just a second. History, yeah, I think 2001. And this is founded by Mr. Eric Blossom, a 5-member community, and the last member is Matt Eaters, who designed the Eaters USRPs. So most of the Eaters USRPs are compatible with GNA radio completely. And regarding this GNA radio, GNA radio is a software framework where it enables the user to design, simulate, and deploy high high capable real time radio applications. And this gene radio is a modular base, and it's based on flow graph model. I think you know about modular based, I think so, just similar to your Simulink. So there are predefined blocks will be there. I can drag and drop and build my application directly. And as I told, this is particularly meant for signal processing and communication related simulation software tool. So whatever algorithm you are having in your mind, you can try to simulate using this tool. And there are predefined blocks are available. That is, I can't convey it as blocks. Predefined libraries are there, so we will be combining these library blocks to create an application, complete application. And basically, like this GNU radio is based on Python and C++. Your blocks are written in C++, and it will be converted on Python, and the interface communication between two blocks will be happening through Python, and they'll be using a FIC wrapper so that C++ and Python are combined. So if you are good in C++, you can write your application directly. So GNA Radio is an open source tool. For your kind information, GNA Radio is an open source tool, and it is meant for signal processing based application. It can simulate any kind of algorithm in your mind while with the help of coding. You can write your application in Python directly, or you can write your application in C++, or else you can use the predefined libraries that are available to create your application. The features are like flexibility and configurability, easily configurable. The disadvantages is like it will take its sweet time to build your application, because see, everything is available online. So you need to browse it properly to for your understanding. What I'll say is I need to steal properly to build my application, frankly speaking, because everything is everywhere in the world. So I need to steal it properly to build my application. And this GNA radio is a kickstart only. So once you are comfortable with GNA radio, then you can write your application in C++. So what exactly is happening now? I'll be writing some application in Python, then it will be converted to C++, then it will be fed into my USRP. So this is the process. If I'm writing my C++ application directly, then it will be can be write directly into my USRP. And I forgot to mention about the hardware USRP. UHD, I mentioned UHD, no, Universal Hardware Drive. Hope the presentation is visible for all of you, sir.
Yes, it's visible.
So I mentioned something called UHD now, sir, Universal Hardware Drive. So that UHD is also open source. This UHD is written in C++. So if you are comfortable with C++, you can write your application directly on C++. And for your kind information, if somebody wants to, your student like a BTech person want to develop a 2G kind of application, so it is not written in GNU Radio. They have written in C++ directly. You just need to download the code and configure it properly to build it. So for your kind information, this GNU Radio is meant for basic kickstart. to have a confidence to move around this hardware and software tool. So once you are comfortable, then you can write your application in C++. So this is the coding in Gnuradio. Python and C++. The signal processing blocks are written in C++. They are using a strict wrapper, and the communication between two blocks are through Python. I think Sarah's presented his Gnuradio companion. So I hope we can share the Gnuradio companion, sir. I'll just stop sharing.
Okay, I'll share.
Yeah. Sir, Maximum.
Yes.
Sir, just move your mouse on the top.
Hmm.
So these are the toolbars, sir.
Okay.
This is called toolbar, and on the right side there are something called audio, boolean. These are the library blocks.
Okay.
Okay, and there is something called import variable on the down.
Mm-hmm.
These are the variable block, and next one is the terminal window. So whatever application if you are doing, it will be running the terminal. You can see it here also, and the center point is called workspace.
Yeah,
Space.
this is
Yeah, that is the workspace. Basically, in any Gnuradio flow graph, two things are predominantly available. If you're opening a new Gnuradio window or a flow graph, two blocks will be default. That is, one is option block and one more is variable block. Option block is nothing but your header file kind of thing. It will be default. So in option block, just double click on the option block, sir. Because I'm having 3.8, it will be totally different. If you are having 3.7, it will be easy actually. So in option block, what are the parameters will be there is ID. So I can mention the name of the block. So what kind of application I'm going to do it. In this name, only the Python file will be generated. And title is nothing but the name of the block. Author, who has written the program. Description, like what is the application. Canvas size is like nothing but your window size, workspace window size.
Okay.
And
I would like to stop you for a second.
please.
The rest of the memory is having the same version or any different version, if they can.
Hope so.
Because everyone wants to understand these things.
No, like say,
right?
option block remain the same, sir. UI will be a little bit different. That is the only different. If I'm showing mine, the UI will be color will be different. That's it.
Okay, that is
Parameters.
Interface is different.
Yeah. Okay. And one more thing is like why I ask you to open it. There is 1, 2, 3, 4. Fifth option is there now, sir. Generate option. Just click on it, sir.
Okay.
See, in 3. Up to 3.7, you can have multiple UIs. That is Bosky GUI, Qt GUI, and WX GUI. In case of greater than 3.8, WX GUI is remote. You will be having only Qt UI.
Okay.
So if I'm opening that, then you won't be having the option. That is the reason I ask you to open it. So in order to view the output, whatever we are getting, so there are below 3.7, there are two basically predominantly two versions are there: Qt UI and WX UI. Either you can select any one of the UI to view the output. In case of greater than 3.8, you will be having only Qt UI.
Okay.
I run auto run only will be making it. Maximum number of output run, no need to specify anything. Real-time scheduling is also not needed for us. QoS theme, the theme of the thing also we are not going to change it. If you are having any files with you, then you can change the theme. Basically, for your understanding, we need to change the ID. So because why I'm asking you to change the ID is sometime what will happen, I will be making it as a first program. So the Python file will be generated as first PY only. If I'm not mentioning the name, it will be top underscore block. And I'll be having 10 different kind of application. For everything, it will be top underscore block only.
Okay. That same name will appear for
everything. So this is not the name of the file. This is the name of the Python file generated.
Okay.
ID. Or else if you want to leave it as such, you can leave it as such. No issues. So option block will be a default block and variable block will be a default block.
Okay.
Clear, sir?
Yes.
Sir, and here there are certain things are mandatory in when you are going for a GNU radio. First, you need to check the data types. Just go on the help, click on the help button. Types. No, sir.
Okay, sorry.
Help types.
Type.
So these are the data types available with GNU radio. So these data types color different color. So one is brown, blue, light green, thick green, yellow. I don't know the color. Blue, orange. So see, different colors are different data types. Actually, if you open a block, if you are opening a block that is a predefined library on the right side, the color coding will be there. The color should be matched. Okay. For example, 2 blocks, if I'm taking it, if it is having yellow color, the other block is also should have yellow color. If red and yellow is there, it won't communicate. That is in the sense the data type is mismatching.
Absolutely, the data type should be same for every block.
Everything. So basically the mistake, whatever we will make it is like the first mistake is this one.
Okay.
And second mistake is option block. So I say right now I'm making it sure like you're not making mistake, and I'm giving the answers directly. Because I don't know like how many of you are having the GNU radio installed in your PC. So whenever I'm going for like generation option on the option block, if I'm selecting Qt, I need to select the UI also Qt. If I'm selecting Qt and if I'm using the WX block, it will throw an error.
Okay.
So data type is also mandatory.
Okay. Great.
Clear, sir?
Okay. Yes.
Close it, sir. Shall we kick started with the simple flow graph, sir?
Oh yeah, sure.
Sir, go and click on the lens button, sir.
The lens button on
In
this
toolbox,
side.
that is a fine. Just search for signal source. Whether it is open, or else you can do one more thing also, sir. On the above the library, above the library.
Okay.
Yes. Click on the above. That toolbox is there, no. Above. Click on it. It's taking too much time for you.
There is no options appearing.
No, it will come, sir.
Okay.
Because we need to select signal source. So if it is not coming, no, scroll down. Waveform generation. Click on the arrow, waveform generation. Signal source. Last.
Okay.
Double click or drag and drop.
Oh.
So you are getting the signal source. From this signal source, what are the parameters are there in the signal source? Double click on it, sir. So what are the parameter? ID I'm not going to change it. Output type. So data type, depending upon data type, I need to change the output type: complex, float, int, or short. Okay, sir. And other parameter, what I need to change it? Sample rate. So here we are making a variable, no? Because in a signal processing flow graph, sample rate is mandatory. So what they have done, no, they made it as a variable.
Okay.
So wherever sample rate is there, the variable value, whatever you are given in the header file, it will take automatically. And right now what we are going to do is, we are going to generate a cosine wave.
Okay.
And the frequency of the cosine wave is
1 kilohertz.
1 kilohertz. Amplitude is 1. And for your kind information, in GNU radio, the amplitude, if you are using an hardware and checking, amplitude won't go more than 1. If you are sending 2 also, while receiving it, it will be below 1 only. That is a mistake with, not mistake, how to tell, like an issue with GNU radio.
Okay, this is the limitation. We can generate up to the maximum amplitude of 1.
No. Like while viewing it, we can see only up to 1 using a USRP hardware.
Okay.
See, for example, like you are doing an modulation and you are sending a signal, sir. So in the transmitter part, you can see like the wave is around, amplitude of the wave is around 2. On the receiver end, it will be below 1 only.
Okay. So it will do the mapping, this kind of mapping, or this?
No. This is the like this. That is the like problem in GNU radio.
Okay,
they have clearly mentioned.
Okay, great.
And one more thing, sir. When you are using GNU radio, it's basically using your. We are basically using it for signal processing based application. So the GPU usage will be more, and your CPU usage also will be more. To avoid that, we need to use one kind of application. We'll do it later. So click on OK, sir.
And this offset is the DC offset?
DC offset, we'll make it as 0, sir. We are not going to change anything. So right now I'm going to make a cosine wave. and you can see two red highlights are there on the signal source. Also, it's highlighted red, and one on the top also in minus symbol also it's showing red. Yes.
Yes.
If you click on it, sir. The error is showing block analog. This is an analog block. No, signal source port is not connected. In the sense, it is not connected, so it is only empty. So I need to have something else to connect it.
Right.
Close it. So, sir, for you it is not coming. Go to instruments, sir. Instruments. Up. Up. Move up, sir. Instruments. Instruments.
Yes.
QT. GeoAsync. QT GeoAsync or anything. UAsync.
GeoAsync. Okay.
GeoAsync. Double click. Sir, click on the one end of the blue color and click on the other end of the blue color for connection. That's it, sir. Now the red symbol is gone, no? So it is connected. And and you can check it in this way also. Just click on the signal source. Double click, sir. Change the output type to float.
Okay, then there's a mismatch of
apply. Your red symbol is highlighted, no?
Right.
So the error is there. Here also it will show the error. Double click on it.
So
Complex. Upper one. Apply. Okay. So right now I'll be getting a sine wave. And in the QT UI sync, just open the QT UI sync. So there are more parameters are there. What are the parameters we will be concentrating is like this FFT size. If you want to have a center frequency, you can mention it here.
Okay.
And other parameters we won't be using it normally for basic level. Higher level we can use it. And if you want to know what are the parameters are there, click on the document, sir. Also the documentation part, something will be there. They will clearly mention what are the parameters are meant for what purpose.
Okay, that we can read out the advantage.
Yeah, advantages. And one more thing now, sir. C++ files are already inside the Gnuradio folder itself. The entire code of this one. If you want to modify and upload it, also you can use it.
Okay, the modification can be done according to our requirement.
But for that, we need to have the core knowledge on C++ and in which way they have written, because it is very difficult to debug a code written by somebody else, no, sir.
Yes, exactly. Okay.
Sir, click on OK, sir. Sir, right now the flow graph is done. First thing what we need to do is we need to save the file first. File. Save as.
Oh, save as?
Anything.
Okay.
Any name, sir? This is documents, no? Okay.
Okay, this is saving documents.
Yeah,
Save.
Save. Done. So first we need to generate a Python file. So there is a symbol is there, no? Blue, red, yellow, nearer to the minus sign, highlight sign.
This one.
This is to generate a flow graph.
Okay.
Click on it, sir. Something it's showing, no? What is warning it's showing, sir? Because we need to learn from the mistakes only.
Sure. So the warning is this flow graph may not have the flow control, no audio or no RF hardware block found. Add a miscellaneous throttle block to your flow graph to avoid the CPU congestion.
Sir, what is happening? No, this is used for signal processing. Basically, if I'm using for signal processing, my entire CPU usage will be utilized by it. Because you're using a maximum bandwidth. Signal processing is also happening. UI is also happening. So what will happen? The entire CPU usage will be utilized by this flow graph. The other application will be stopped. So when I should not use throttle block is they are clearly mentioned. If I'm using an audio block, in audio I'll be mentioning the sample rate. Yes.
Yes. Okay.
And if I'm using an hardware, USRP hardware, there also I'll be mentioning the sample rate. So that much amount of data only will be processed. Here I'm using a sample rate, but the entire CPU will be utilized. In that way only they have written. If I'm using an audio block and if I'm interfacing with an USRP hardware, no need to use throttle, or else I need to use a throttle block. So go to miss, sir. For you, the search option is not working, or else it will be easy for us to search it.
Yeah, this option is for Acha.
Yeah, same one.
Okay, we can search it here.
Yeah, please, sir. Say yes, sir, please.
So I was also doing the same steps, but I'm getting an error that param ID default is blacklisted. So I'm using 3.8.
Sir, put a name as something, sir, and the ID part. On the ID part.
getting
In
an
ID,
ID.
SAR is using no. In the option block, SAR is using ID as top underscore block. No, it is mentioned as default. Put some name.
This one.
Yeah, put some name.
Okay. I'm using 3.8. I'm not
Hmm.
getting this
No.
ID.
You will be getting, sir. Just change it. Option block. ID. Open option block. Or else, Rahul sir, just uh,
I double click on the signal
Okay,
source.
Asrar, if you can
not
share
signal
your
source.
screen for once,
Yeah,
it
it's
will.
not the signal source, sir.
Okay, just
It's not the signal source. It's the option block.
okay. Okay, let me share the screen.
Yeah.
Maybe
Please,
I
please.
have missed something. Uh, is it visible?
Uh,
Okay,
you
okay,
you are getting a red mark on where option block.
okay. This
Option.
one.
Double
Okay,
click on it.
so okay, okay, got it.
Instead of default, put some name.
Okay, thanks.
Stop sharing. Sir, sir, don't. Sir, you stop sharing. Just share it one more time. You can get the difference. In 3.7, the lines will be straight. In 3.8, it will be the UI will be more user friendly kind of thing. Curve will be there.
Okay, so you want me to share the screen
No,
again?
no issue, sir.
Okay.
I thought of informing to Rahul, sir. Rahul, sir, you can share the screen, sir.
Yes. Yeah.
The flow graph is created, but we are having problem with the throttle block. Just click on the search, sir.
Yes. There.
Throttle, TH. Throttle.
This one.
Double click on it. So how to delete is click on the arrow mark and press delete.
Okay.
Delete. Just you can move it, sir, so that you can place it here. So
Right.
here you can define the sample rate also. See, for example, here also sample rate parameter is there. If you want to send more data, you can change the parameter. Or else if you want to keep it as such, you can keep it as such. No issues.
Okay, so after the signal source, we can change the sample rate here also, the throttle block,
Yes.
and then it will control the sampling rate.
Yes. So the UI.
Okay.
For UI only, we need more CPU usage, no, sir.
Getting.
So if anybody is using Ubuntu, then you can run your Python application directly, because once the generation of flow graph is completed, a PY file will be generated. You can run it directly. But here I don't know, like my system is not also having Python properly.
Okay.
You can run it, sir. Generate a flow graph one more time. So the name of the Python block is top underscore block dot py. It's already created. You can see the result in the terminal. Clear, sir?
Okay.
Now I'm just going to execute my flow graph. So for that, click on the play button next to that generation of flow graph. That won't be an issue, sir. Click on OK. Already open. Maximize it, sir. This is FFT. Our frequency is 1 kilohertz. No, it's showing exactly in 1 kilohertz. Little bit here and there will be there.
Okay, so it is representing the frequency domain of the sine wave, and that impulse we are getting at 1 kilohertz.
Yeah. Second is water flow.
What is water flow?
Second option is there, no, sir. Frequency display, water flow display. So you'll be getting spike. See, these displays are meant for in where, no, if you are using for frequency spectrum sensing and some kind of application, and you want to check in what are the spectrum in what are the spectrums are free and which are highly utilized, you can use this water flow, colorful.
Okay, so this is representing the same thing, but the presentation view is different.
Different, colorful.
Okay, colorful.
And see, these are basically used for GSM sniffing, spoofing kind of application, where they need to find the exact frequency. And there is so one more tool is also there, sir. It's called phosphor. Time domain. Next is time domain. So why it is showing two is like we are using complex. Complex is having a real and imaginary. It's showing the real and imaginary part of your cosine wave. See,
this combine is a cosine wave, or we should consider only one wave for our?
No, sir. It's IQ, no. In phase and quadrature phase.
In phase and quarter. Acha, real imagery is
Yeah,
showing
yeah.
here also.
So if you are having confusion, close it. Just close it. Close the flow graph.
Okay.
Just if you close it, it will be stopped.
Acha.
Change the data type. Close it. Close it, sir. Close it.
Just close it.
Change the data type.
For the sig.
Output type should be float. Apply. Okay. Same in throttle also. I need to change it. Apply. Okay. Run the application, sir. Now. But in frequency domain, you'll be getting 2 in float.
Yeah, plus minus both.
Yeah, plus minus. But here it will be 1 cosine.
This is a common solution. Okay.
Sir, sometimes what will happen? No, if I'm this same application, if you're running an i7 machine, the response will be better. If I'm using with a dual core or i3, the response will be little bit cracky here and there.
Okay.
Because it's using the UI, no. So the response will be slow if I'm using a lower version of machines. And you should not feel bad also. Sometimes what will happen if you're using an FM transmitter or FM receiver with USRP in GNU radio, if I'm using a dual core machine, the audio clarity will be very low. If I'm using an i7 machine, the clarity will be very good.
Yes. That's the machine's idea.
Yeah, that depends on the machine. Just close it, sir.
Okay.
Hope it is clear, sir.
Yeah, it's
Somewhat.
clear.
Then you can change the sample rate and check whether it is sampling the Nyquist criteria is achieved or not. See, this is basically meant for student purpose. So if you are teaching to the student, this is the way. And GNU Radio is particularly meant for that kind of application only. In order to visually show the students like this can be done. This is we will be explaining theoretically. This is Hamming window. This is low pass filter. If I'm using this windowing technique, this will be the output. See here practically I can show them like if I'm giving this
The
value.
visualization is easy here.
Yes, exactly, sir.
Okay. So the sample rate, the value I need to provide here.
Or else you can change the center frequency, frequency of the signal.
Yes.
So it's fixed, so you can change it to 17, and you can check how the sine wave is. And while making in the frequency part, it should be 17.
Sorry.
Click on the signal source, sir.
Okay. Just yeah.
Instead of 1, make it as 17. 17 000. Apply. Okay. Time domain, sir.
Okay, we can zoom.
Distortion is there, and compared to that, so you can change it, and you can add 2 signals and check how the addition, multiplication, everything is happening here. You can make an AM modulation also here.
Okay, so these are simply block we need to add, and we provide the source, and then it will present it. Okay.
Yes, sir. So the first 2 blocks are meant for signal processing. The last block is meant for viewing the value. If I want to transmit transmit some information, same the signal source, whatever I'm having, I need to transmit in a particular frequency. Just go to the library file, sir. Close it. Scroll down. There's something called USD will be there. Above variable. If I want to send it, then I need to use sync. USRP sync. Double click.
Okay.
If I want to receive it, then it should be source.
Okay, so this file will be sending to the USRP.
You see here I'm using a QTUI to view it in my system. If I'm having an SDR hardware, just I need to remove it and I need to connect this one. I need to mention the center frequency. That's it. It will transmit the information directly.
Okay. So how it will going to get the information? What USRP would we are using?
Double click on it, sir. A little bit maximize it, sir. Because see here the parameters. What are the parameters we need to check it? Like something called device address is there, no, sir?
Yes.
See in our campus we are having network series and X series. Okay. Each and every network series and X series having a particular IP address.
Hmm.
So basically,
Right.
I think so. We have not changed the IP address of the network series and X series. Whether we have changed the IP address, sir?
This idea I don't have. Kagenda sir can provide.
Okay. See, for your understanding, I'm just telling. See, for
Hmm.
example, like each and every USRP devices are like connected to a single system with the help of a router. Okay,
Right.
and you are remotely accessing it. So what I'm having 4 devices.
Hmm.
So first device is 92. That's
Hmm.
192.168.10.2. Second is 3, 4, 5.
Right. Right.
Here I can mention the device address. So program it to this guy and send the information.
Okay. Okay. Oh, okay. I got it. Like in the USRP, you use the utility tool to check
Yes,
the
yes, same,
IP.
same, same, same.
Okay.
If you're making it empty, no,
Hmm.
first it will check for the USB
Hmm.
and it will check for the first Ethernet that is connected.
Right. Right.
The
Absolutely.
and the thing when it will be matter for the remaining parameters like sync, clock rate, number of boards, and when we are going for synchronization purpose, and when you are going for like if you are going for X series, there are 2 channels are there. So
Hmm.
here I can mention number of channels are there. No, when changing
Yes.
it to 2, then you will
Hmm.
be getting 2 RF options available.
Okay.
In the RF option, just go to the RF option, sir. Right now you'll be getting only one
Hmm.
RF option. Next one. In general, after general, you're having RF option, no? Ah. So first thing you need to mention the device address, because for basic application we are not going to change anything. Sample rate also remains the same. Whatever
Hmm.
we are giving in the variable, we will be using. But if you want to change it, here you can change it. No issue. The main
Okay.
part is like RF option. So what is the center frequency you are going to receive the information or transmit the information?
Hmm.
Whenever you are mentioning here, just for your kind information, sir. So I need to transmit the information in 108 megahertz. So what
Hmm.
is the parameter I need to mention is 108
Hmm.
E6.
Okay.
Just type it, sir.
It will select that. 108.
108 E6.
Oh, okay.
It's megahertz.
Okay. Right.
And gain, if you want to increase the gain, you can mention the gain 20 or 30. And for your kind information, whatever USRP devices you are using with ETS or NA also, the transmission power is from plus 10 dBm to plus 18 dBm, in between the range, that depends. While receiving it, the power is 0 dBm only.
Hmm.
So and when you are providing a value through GNU radio, don't give more than 30.
Okay. So it's
Yes.
it's depend on the USRP board how much it will take
No, no,
or
no.
different.
Each and every USRP having the same parameter only.
Okay. Okay.
See, and the best thing about this device is now, if I write an application for bus series, it will work for network series also, it will work for X series also. The only thing is, like in bus series, I won't mention the IP address. In the network series and X series, I'll be mentioning the IP address.
Okay. So this gain will be going to for our the
Transmission.
signal,
Yes,
transmitted signal,
transmission,
right?
transmitted signal.
So for here example, we have set it to the one peak to peak, for
Yeah.
example. So it
Uh-huh.
will enhance that value in the
Yes, yes,
USRP.
yes, yes. Because I want to cover some area, no, when I'm transmitting.
Yes.
It's
Yeah,
just an
that was
amplifier.
right. Right. I got it. That was my concern because for the one amplitude, if I'm taking a 10 centimeter distance, it might get distorted.
Yes, sir. Yes, sir.
So, okay. So the gain value option is there also.
Yes, sir.
Okay.
And next option is channel gain type. No need to mention. That is not a part of us. Next, antenna. So here I'm using a transmitter. So it's showing TXRX.
Mm-hmm.
If I'm using as a sync, it will show TXRX or RX2.
Okay.
Here it is a sync. No, only transmit can be done.
Mm-hmm.
If I'm using, see, right now you have the option of just go to the general, sir. Just go to general. Change the number of channels to 2. Change the number of channels to 2. Number of
Yes.
channels to 2. Go to RF option, sir. 2 channels are coming now, right now.
Mm-hmm. These two informations.
Two
Yes.
information I need to provide. If you are, for example, like in which case it will be useful, no? If I'm using X series, so it will be having 2 transmit and 2 receive. So how many
Yes.
channels are there? 4 channels. So I can
Two,
select
two,
4
two.
channels, and each and every channel I can mention whether in this receiver need to receive the frequency in this center frequency.
So
This
we
receiver need to receive the frequency in center frequency in this parameter. That way you can manage it.
okay. So with the X series, we have two daughter boards for each TX and RX, and we have 4 options. Okay.
Yes, sir.
Okay.
Yes, sir. And one more option is also there. But if you have the device, then it will be useful. Go to general, sir.
Okay.
There is something called motherboard sub device spec is there, no? Below. Next, that gray color is there, no? Brinjal flower color.
Okay.
Above the here,
Above
sir.
the
MBO sub device spec.
yeah, there's one.
Here I can mention 2 channels are there, no?
Right.
So I want to access only one channel. For example, like A channel, B channel is there. 2 channels. I don't want to use A channel. I want to use B channel. If I'm mentioning B.0, it will access only the B channel.
Okay. So the channel we can specify.
Yeah.
Although we can provide them information, we have 2 channels, but at the time what we are using, we can.
Yes. Okay. See, that depends. Like I want to use only the B channel. See, A channel is the default one. I don't know. See, for example, like I'm having 2 RF data records. One is WBX and one more is SBX. WBX is meant for the lower frequency rated application. I'm going to use it for a MIMO. Then I need to use SBX. At that case, I need to mention B:0. To go to documents, sir. The parameters how to mention it. Sir, once you get into it, no, it will be easy. Then you can ask too many questions to me actually, because this is newer one for us. So whatever is I am conveying, we are just taking it.
Yes.
Scroll down, sir. Sub-device application is sub-device. Here they are mentioned. No? So in which
channel example, okay, and dual channel examples.
So in case of twin RX and all, I'll be having 4 channels. So how to access? In that way, you can access the device.
Okay, these are the how we gonna select this. These are the writing parameters.
Yes.
Okay.
So basically, if I'm going for an USRP transmission and reception, I need to set the center frequency, antenna parameters, and sample rate, and the device. If I'm using an USB, and if I'm going to use only one device with my PC, then no need to mention anything else. I can directly interface it. If I'm having multiple devices interface, then I need to mention the device address.
Yes, great.
Whether it is going to transmit or receive.
Okay.
Sir, this is fine. Then we can go for one more option is also there. Yes. Close it. Right click on the UHD USRP sync. Right click on the UHD USRP sync. Disable it. So it will be disabled. Whatever you don't want, you can disable it. Sir, right now I can able to generate a signal, and I can able to view the signal in the Qt UI. It's clear now, sir?
Right.
If I want to change the signal frequency during the runtime itself, as a slider kind of thing, so that it will be useful for you to do some kind of application faster. So go to that UI, sir. UI Qt. Just click on the search button, that find, and type on Qt. Please type Qt. There is something called slider will be there. Slider or range, Qt range, Qt UI range, Qt GUI range. Sir, below. Next one. In GUI wizard, last second. Next one. Above one, sir. Qt GUI range.
Okay, get it.
Double click on it, sir. So right now, what I'm going to do is, previously I put 17K, no, manually. Here I'll be making it programmatically, directly. So double click on it. Instead of this ID, please mention freak, FREQ, some variable, any name. EQ, something FREK or EQ, something.
And,
default value is, we'll make it as 1K. Make it as 1K, 1000, sir. Starting also 1000. Make it as 1000. Start.
It will take 1E3 if I like.
Yeah, you can take it also, no issues. You can go up to 15, no? After that, the signal will get distorted, no? 15 E3. Number of steps, 100. Or one step, it will take more time now, sir. Apply. Okay. Here, double click on this signal source. Instead of that 17 kilohertz, put the variable free. Apply. Okay. Run the application, sir.
Okay, we do not need to connect it. It will take.
No, it's a variable. No, it's a variable kind of block. You can change its frequency. Above. Freak one parameter is there, no?
Right. I'm just checking what it is. Right now it is 1K, right?
1K.
Plus minus 1K. Okay.
It's changing.
Oh, it's changing. Okay.
You can check the difference in time domain directly. Nyquist criteria.
Yeah, at the lower frequency and at the high frequency we are getting to. Okay, that's a great option. We can visualize the
Yeah, we can visualize.
frequency
Yes, sir.
on the run also. Okay.
Here also you can change it. View it properly.
Mm-hmm. Okay, great.
Sir, basically, the basic parameters what we will be using to view the output, to generate a signal, and to vary something. So three options are completed right now.
Yes.
So you know how to make a signal source, and you can check with different waveforms. If you want, you can check with different waveforms
Mm.
at later part. So you know how to generate a sine wave,
Yes.
cosine wave, and how to view it, how to vary it, because these three things are mandatory to do some kind of simulation based application with GNU radio.
Yes. If I want to check for example,
Yeah,
square.
yeah, I can
Okay.
check with that.
Okay. And the rest of the thing will remain the same.
Remain the same, sir. No need to change anything.
Yes. Okay. The multiple frequencies will come. Right. Then we have time. Okay. Yeah. It's absolutely right. Okay.
Sir, right now what we are going to do is we are going to add two signals.
Mm-hmm.
Add or
Okay.
multiply will be better now, sir, or add will be better.
I think addition will be a better option.
Okay, just search
Multiplication
for
will
add,
be.
sir. You need to remove qt.
Yeah. Sure.
Add, third option.
Mm.
What happened? It is disabled.
This is red right now.
No, like I think you have disabled this one. I think so, sir. Enable it, sir. This one. Our signal source and other things are disabled.
Oh, okay. These
Okay.
two.
And qt UI range also need to be enabled. Option bar also need to be enabled. You have selected no at the time it got disabled actually. Option black option
Right, just give me a second.
and variable will also need to be enabled.
Okay, so when they are not active, the color changes too. Okay.
Yeah, yes, sir. Right now also the red signal is coming. The reason is like this block is not connected, so I need to have one more signal source.
Can I copy and paste
Yeah,
it?
yeah, yeah, yeah. Right click, copy paste.
Okay. Hmm.
Uh, um, Remove the connection between throttle and that source.
Right.
Remove it, sir. Put the add. Color red color symbol is there now because data type is in add the data type is complex. We need to change to flow. In add also you can have number of channels also. If you are having 3, 4, 5, you can change it. Right now we are having two inputs only, no? So we are taking two inputs. You can run it, sir. So it is a square wave. That is also square wave. Two square waves are added, and it need to show the output. 4. 1 plus 1 2.
Okay, for the same set of data we are taking, let's
Yeah.
change the
Change.
data.
Yes, sir.
Okay, we are taking this from the variable point of view.
Square
If I
wave.
want to fix it, I can
Yeah,
provide a value.
yeah, value here.
Okay.
Sir, but it's square wave now, so we can't get the difference, no?
Mm-hmm. Change the view.
Sine, cosine. Thanks.
What's up? Mm-hmm. Both
Yeah.
5 and 10 are coming. Yes. Okay. Mm-hmm.
Sir, right now we added two signals, so it's adding and coming. So what we need to do is, after adding it, we'll use a filter to remove one signal.
Yes, we can use the filter. So the filter we can apply on this. Here we can apply the filter, which frequency we want to.
Yeah.
Replace. Okay. Should I try that?
Low pass filter, any filter, low pass filter is there, sir. Because why I'm asking you to go for this one is I'll explain you the parameters. Then it will be easy for you. That is the reason.
Yeah. Okay.
WD connector. So first we need to change the data type, FIR type, float to float. Sir, here we are having two type of filters, decimating as well as interpolating. So whichever you want to select, we can select. We'll go for decimating filter itself. And decimation also we are not going to do anything because it's not meant for signal reception or something else. So I just need to mention the low cutoff frequency, whichever signal I want to.
This cutoff frequency, for example, I want to block 5K.
Yeah.
So.
And you need to mention transition width. Number of taps, that is the transition width. 10 or 100, any value. And we can select the windowing also, hamming or whichever window you want to make it.
Okay, let's set it to hamming. And what this? Achha, this is depend on Windows.
That for Kaiser only beta value will be coming out.
Right. Okay. So should I run it?
Yeah, you can run it, sir.
It tapered the file.
Yes.
Beyond that 5K,
Yeah.
it tapered the frequencies. Okay. Yes. Right.
And right now it is done. UI part is completed, sir. Just close it, sir. Sir, hope everyone is understood, sir. Or we both are only communicating?
No, I understood. Okay, one more thing
We are
is,
following.
yeah,
please.
how to change the phase. Like in my GUI, I have that option of initial phase in radians, but it doesn't take pi as an option, like pi
Where,
by
sir?
2 or something.
Where?
When I change this signal,
Signal source.
signal source, yes, there's an option of initial phase in radians. So, but when I write pi by 2 or something, like it doesn't take pi
Sir,
as
that is a newer version, sir. Here, that is
yeah,
the reason. That is the
exactly.
reason I told you. In 3.7, it is not there.
Yes. Okay.
So Asra, that change in phase is not reflecting in your waveform or what?
No, it doesn't
It's not taking the input itself.
It's not taking the input as pi. So, like, do I have to convert it to
Yeah,
3.1?
numeric value. Just convert to numeric value and check
values?
it, sir.
Okay, thanks.
Sir, we'll just move to the next one, sir.
Okay.
Sir, right now what we are doing, like I'm adding two signals and I'm viewing it in a UI. So instead of viewing in an UI, I'm just going to hear it in an audio.
Okay.
So just remove that Qt UI.
Okay.
Disable
QT.
it. Disable it.
This one?
Disable it.
Okay.
Go to audio in the library files. Audio. First one will be audio.
In the library files.
Audio.
I close it and audio. Okay.
Audio. So sync. Audio sync is nothing but my mic speaker. Audio source is mic. Sorry.
Audio sync, right?
Connect it, sir. Here, I think our speaker sample rate is 32 kilohertz or 44.1 kilohertz. If I'm not wrong. You can change it. Default is 32K because it's taking the variable, whatever we are given. So here also you can change it. Click on that arrow, sir. The sample rate, the arrow. You can select anyone.
Okay.
Apply. Okay. So instead of, right now, no need to use throttle. You can remove the throttle block because audio sync is there, no? So no need to use. If you want to use it also, you can use it. Don't be an issue. No, sir. Once it disabled, no problem, sir.
Okay, it will be just bypass that.
Yeah, it will bypass that. We just need to connect these two. We just need to connect the yellow part of this and yellow part of that. That's it.
Okay.
You can able to hear it, sir. I can't hear it. Just run the application and check what kind of audio you're getting. Some frequency part will be coming.
Yeah, it's a beep.
Yeah, 1K now, sir.
Yeah.
5K. It's 5K, no?
It's
5K.
5.
5K, sir.
Yes,
We can't change it now. You have fixed the frequency, no?
right. Okay.
So why I'm explaining this one now, sir? See, everything is mandate actually. If you are going for an basic level, kickstart level, I want to use a FM receiver. So signal source is there. I have filtered it. Then I need to use a demodulator. After the demodulator, I'll be using a audio sync to hear it. So what is missing here is my demodulator. Hope it is clear, sir.
Yeah, it's clear. Okay, one question that we can select some inbuilt audio signal and transmit it and can hear
Yeah,
it.
yeah, yeah, yeah. The
Okay.
only problem now, sir. Do you have a WAV file in your system?
I,
.wav.
I don't check.
No, not
That
audio.
file is not there. Okay. No
Or
problem.
else what we can do is, take we can try. I have not tried in that way. While Google Meet, take an audio source. It will take it mic. Audio sync is nothing but our speaker. You can check it.
Okay, so the source is what we are speaking right now.
Yeah, yes, sir.
Okay.
Sample rate 44.
2.1.
Apply OK.
Okay.
Disable other parameters. Disable. Low pass filter also please disable it, sir.
Oh, yes.
Sir, and one more issue with this GNA radio, no, we can't play an MP3 file in GNA radio. So there is
Okay.
only one. Here also you can see, no, wave file sync, wave file source. Those are the two blocks available, libraries. So if you want to make it, we need to make it by ourselves. Hope so. Whatever you are speaking, we need to hear.
Hello. Okay, yes.
It's
It's
audible, sir?
coming.
Yeah.
Yeah, it's audible. That's good.
So it's pretty simple, sir. But the
Mm-hmm.
complex things is also there. We are not touching the complex thing as of now.
For the basic things, yeah, it's great.
Sir, and there are one more parameter. See, these are the basic things. There are one more parameters also there. There is something called byte operators and Boolean operators is there. No? So, see, for example,
Yes.
like these are and or not gate, whatever you want to use, you can use it for basic digital signal kind of application. Like I need to not the signal, I need to and the signal, two signal, I need to or the two signal, you can use it. And there is a separate thing called type converters are there. Just search it for type converters. Type converters. Should be there. Or else I am missing it something. Sir, remove it. Sir. No, click on the scroll down, sir. Completely close. Scroll down, sir. Type converters will be there. These are plug streaming. USB. Type converters. So see, if you want to change character to float, character to short, sometime into float, short to char, I can use this one because certain blocks doesn't have this option of changing the data type. It will be always, for example, if I'm taking a random source, it will have only two byte and something will be there.
Okay.
So at
So
that
then
time,
we will add these block
yes,
and it
yes,
will come. Okay.
yes. And as I told now, sir, this GNA radio is only meant for basics. So what exactly we are doing? No, I'm writing something on C++. It is converting to Python. That Python file is again converted to C++, and it is dumping into the USRP. It's like instead of going in a straight way, I'm going through a long route and going to the destination.
Right.
Once you are familiar with everything, algorithm writing and everything, you can write your application in C++ directly. For that, GNA radio is not needed. You can write your application in C++ directly using USD. And when we are kicking start with GNA radio and USD, my humble suggestion will be take a Ubuntu operating system, open source Ubuntu operating system. First install UHD, then install GNA radio.
First we need to install UHD.
UHD because depending upon the UHD bill, GNA radio will be built. If I'm installing GNA radio first and UHD, both will be working separately. They won't interconnect.
For Ubuntu we need to do this. Okay.
Sir, can we make a dial tone right now?
Yes, how to do that? Yes.
Sir,
Okay.
hope everyone is able to follow up now, sir.
Uh,
Yes.
if anyone else having any query, you can ask.
And sorry to interrupt, sir. For your kind information, there are predefined applications already available in GNA Radio.
So
Uh,
how to access if
yeah.
anyone
So,
you can.
just to this is Windows now. If it is Ubuntu, I can able to help you. Just go to File,
Why?
uh, Open.
Mhm.
I don't know where the. I think it will be in C. I think so, sir. Your GNA Radio folder will be there, no? Where it is? Program inside program files. GNA Radio where you install. While installing, it will show the path actually.
Yes, I got your point. Jenny Radio, it might be in the next folder. Okay. See program files.
3.7. GNA Radio 3.7. It's there, sir.
Yes,
Double
yes.
click on it. Uh, PCR includes. Go and click on include, sir. Here you can find the codes. Go and click on GNA Radio, sir. Analog. So you can get the codes, complete code here. GRC files are missing.
Okay.
So we just need to find where the GRC files are there. It's not in includes. You click on USB, sir.
Which one?
USB.
UHD. Okay.
Actually, in Ubuntu, you'll be getting the GRC files directly.
Okay.
So no need to go here and there. Here
Okay.
we need to find where the click on GNA Radio 3.7. Sir. Once again, sir, I myself will check in my system and get back to you. Sir. Just add two signals and create a dial tone, sir. In the meantime, I'll just check and get back to you where
Okay.
exactly the files are. Rahul, sir.
Yes.
Sir,
Yes.
just go to the folder, file,
Open.
open, some
See.
program files, GNA Radio,
Mhm.
share, share, share,
Share.
GNA Radio,
Mhm.
examples.
Mhm.
Here you can find analog. Just double click on analog.
Okay.
Inside this one, tone melody is there. You can't understand, sir.
Okay. They have created this
Yeah,
file.
yeah.
Okay. Okay.
In the same way, this is for noise power kind of application.
I should run and check it.
The problem is no, like we don't know in which way they are written.
Mhm. So it will display something
Yeah,
that we
yes, sir.
can understand.
No, see, it is taking file from something else. I think so. It's showing an error. Cannot open a file C program. Share the example. Unlock the error. No such file or directory showing.
So it's saying there is no such file present.
But
Okay.
file is there already.
Right. Let me check it with this way. Okay, we were in the. See, that's why it's displaying. Okay, just a minute.
In Windows, it's straight. In Ubuntu, it's straightforward, sir.
Mm-hmm.
Only in Windows that we have so many issues. GN Radio. Sir, go and click on GRC, sir. Yes, sir. GRC. Blocks. Here you can get the block information. XML files. Complete.
Okay.
So click on back, sir. One more left. Examples.
This file is there. This Python
But
support.
this is Windows, no.
Mm-hmm. Okay,
I
so
also
is
don't
it
have Ubuntu, or else I can help you also.
okay? So for these examples, we can run these inbuilt examples right
Yes, yes,
now.
yes.
What was the issue is not clear. Why
I
this
think
is
it is
not able
it is
to?
permission something issue is there. I think so, sir, if I'm not wrong.
Okay, okay, we can figure it out by performing experiments. So
So
what
say
next
why
we
I'm
can do?
why I'm asking you to do that one is like we'll be having that feel actually. So it is
Mm-hmm.
there inside examples audio. Dial tone is there.
So, but it's not getting.
Or else we can able to recreate by ourselves after seeing it.
Okay, the same block structure we can recreate.
Yeah,
You're saying.
recreate.
Okay, okay.
Open.
Let me open it where it is.
Sir,
See,
C
program file.
modify share GNU radio examples audio audio, sir, audio
Okay, okay. Phone
audio
call.
dial tone
That. So
same
it's the same thing.
same thing.
Let
Sorry,
me run.
hope so. Same, sir. No, it is working, sir.
Yeah, it's working now. I'm receiving some audio tone. Mhm.
In 3.8, I think Syed sir is having 3.8. We'll be having more codes in 3.8. If I'm not wrong.
I think everyone can listen this if I share it by this. Just give me a second.
Yeah, please.
A tab and this file name is JNU Radio. Oh, okay. I think we can continue. I was searching that we can have some way to everyone can listen.
Yes, sir.
Okay. So it's working, right? It's
Yes, sir.
absolutely working.
So in the same way, you can have direct source code for your FM receiver kind of thing in UHD folder also. So
Hmm.
everything is there. So why I'm showing this one is like after this workshop, you should not feel like I have not done anything.
No, no, no. It's
So
great.
this is a
Yeah.
kickstart. Everything is there. So you just need to like go through it and make it happen with the examples. Some examples will be very difficult. For example, like if you are going for OFDM kind of thing, the examples are available for OFDM also here, but it will be quite complicated to understand. So basics like tone, melody, those kind of things can be done.
Okay, it will be great for students also. They are going through the lectures of OFDM modulation scheme. They can visualize it.
Yes, yes, sir, yes, sir.
So, okay, they have inbuilt examples, so they can learn how to build these things.
I'll just show you, sir, if possible. Just a
Sure.
second. Sir, hope it is visible, sir, but it is quite complicated. The codes are already available for receiver separately, transmitter separately, and this is like loop back in the same device to check it whether we are getting properly or not. So the same way, similar to the signal source, there is vector source is also available. You can put a range there. Then they are converting this stream to tag the stream. Then they are doing a
Uh,
WebDM
yeah.
transmitter.
Mr. Patel, is there any way, like in the MATLAB, we used to show everything in the form of matrix, what every block is processing. So if I want to see that after vector source, we are moving to stream to tag stream, right?
Yes, sir.
So
Yes,
what
sir.
stream to tag stream is doing, how we can, in the display option, we can have
Yeah,
something.
yeah, you can see UIs are there. You need to select like whether you are going for histogram, sync, or time, or vector sync.
Okay.
Here it is there,
So
no, sir.
if you run this, for example, if you run this and
Uh,
at any stage I want to see what is the
hmm.
output coming, for example, after channel model, what is coming out, how I
Yeah, you
can
can check it,
visualize
sir. So whether I need to go for frequency or time sync, sir.
the time signals.
Sir, sorry, I have not named it. Whichever is not named, that is ours. This is the this is after your channel model.
Mhm.
That you can make it, sir. So we need to name it actually. So here they have mentioned
What new convention you're telling?
here it is there, no, sir. QTGUI name. Here they have
Yes.
mentioned receiver spectrum.
Okay.
I made it empty. So if I'm naming it, here it is mentioned as scope plot.
Uh, okay. So the plot we can name it. We can
Yeah, you
change
can
that.
name it and you can see it. For the same, whatever Rahul sir has done also, you can do it in the same way.
Okay.
So do you have any doubts, sir?
No, I think anyone else having any doubt, please ask.
No.
Sir, could you please make a dial tone and show it to me? Rahul sir has done. If any of you is having your Gnuradio install, could you please do me a dial tone?
Your dial tone using that example, right?
Yeah.
Just a minute.
In the meantime, if possible, I'll just show you a flow graph from ETS.
May I share the screen? Hello?
Yes,
Yeah,
Asrar is
you can
visible.
share it. You can share it. I'm sorry.
Hmm. Yes. So it's that example. Dial tone. So, yeah.
Different tones are coming, sir.
Yeah, it's coming. Like I can hear
And
it.
see, if somebody is having a wave file, .wav file, you can use a wave file source and you can check with audio sync with a different sample rate and you can hear it.
Asrar, do you have any song in your system
No.
playing back? Okay.
So any WAV file, sir, if you are
No, I
able
don't
to
have
upload.
any WAV file in here. And this is on 3.8. I mean, I'm doing it on 3.8.
I can able to see the difference, sir. The curve in the connection.
Okay.
because in 3.7 and older it will be very straight.
Okay.
And one more thing is the command and that part won't be there. The message part won't be there.
The message part means this one is here, like.
No, like not that one. In the signal source, you are getting an output on the other side, and on one more side it is showing command and FREQ.
Yes.
That won't be there. In the latest version of 3.7, it will be there. The older version of 3.7, it won't be there.
Okay.
UI itself will be different, sir. Your UI will be better. When 3.7, it will be like a old system kind of thing.
Okay. So I stop sharing.
Yeah, you can stop sharing, sir.
Mr. Pandey, you are on mute. Are you sharing something? Speaking something?
I'm sorry, sir. I was explaining one more time, but not seen it
Okay.
like this. I'm sorry.
Can repeat.
Sorry, sir. Sir, basically, I'm just refreshing it. This is the toolbox. This is 3.3, so the UI will be like this only. This is toolbox. This is your window for programming. This is the terminal. This is the predefined libraries that are available with the GNU Radio. So the basically, if you are opening a GNU Radio, two blocks are mandatory. It will be coming default. One is option block, and one more is variable block. So variable block is always sample rate. So if you want to create a one more variable block and use it, you can use it also. See, for example, like sometime I need to use a frequency in two or three different blocks. I can use this variable block to make it. So this is the optional block. You can get the difference also. Here it is mentioned as window size. In R block, it will be mentioned as canvas size. So there are certain changes they have mentioned. So ID should be named to check the Python file that is created. Title is nothing but the title of the program, whatever we are doing, and the window size and what kind of UI we are using. We need to mention it here. So we learned about signal source. Can Noise sources block is also there. You can check with noise source. Random source is also there. There are different type of sources that are available. If possible, if you have a wave file, then you can check with audio source and audio sync also we have completed. If I'm not wrong. And this block is somewhat mandatory for user. When it is mandatory is like if I'm using for some kind of audio related application. For example, like I'll just show this flow graph example I'm just taking. See, here I'm having a sample rate of around 32 kilohertz. So I'm having an audio block here, and the audio block sample rate is 44.1 kilohertz. So I need to upsample the signal. So and in that case, I'll be using this rational resampler. So I'll be using interpolation value and a multiple on the multiple to get the exact 44.1 kilohertz. So in case of, for example, if I'm using for an FM receiver kind of application, So while receiving the application, I'll be using a sample rate of around 4 megahertz sample rate. But my audio speaker sample rate is 44.1 kilohertz or 48 kilohertz. So I need to convert this 4 megahertz sample rate to 48 kilohertz or 44.1 kilohertz. At that time, I'll be using this rational resampler. It's nothing but a interpolation and dissipation value. So there are predefined AM mod, AM mod blocks are available, and the source code is also available in the example folder of your GNE radio. You can use it directly. Any doubts, sir?
No, I think it's clear. Everyone, I hope it's clear.
Sir, did any of you able to uh, get a WAV file? Shall we do an FM transmission? I'll show the flow graph, or it's already there. You just need to have a sine wave. Then you need to have an narrow band or wide band FM transmitter. Then we need to have a multiplier. Then one more signal source. Then USD source can do it. But I don't have a flow graph with me to show you. That is the reason I'm just asking you to check. If you have a wave file, then we can go ahead
I
with the
think we
wave.
can download a wave file in a second
Yeah.
and then we can test it. But anyone is having a wave file in their computer, we can present. Okay, yes, I have downloaded two wave files.
Okay.
Now let's proceed with this.
Sure.
So go with the
Same.
now I have
New. New. QTR.
uh, should I rename this top block? With this?
Yeah, you can rename it. Sir. Double click. Put some name. Sir.
I think it best.
Audio. Wave test.
Now the
Just click
block
on the audio. Click on the audio.
is
Last option, wave file, source,
wave file source.
source. Then audio sync,
Just audio sync.
audio sync. Connected. Sir. Just double click on it, wave file source. So here there are only two parameters are there. I need to mention the file location, whether it need to repeat or not to repeat. So we need to have a repeated one. So just need to browse it and in the downloads it will be there. I think so that we have downloaded. Saved in the desktop, sir. Or else you can stop sharing and you can find the location where it is.
This is the location. Acha, we can't paste it. Okay.
Oh, you can't find
So we are in
the
C
downloads.
download.
No, it's not showing here.
Just
Just stop sharing and check it, sir, once.
okay, yeah, sure. Yes, I got it. Just hmm. So this is the wave file digital presentation
Hmm.
dot. Okay.
Okay. Apply okay, sir. Oh, run it, sir. You can hear it in the audio file. 32 kilohertz. We'll just check it. It asks for the name. So you need to save now. We have not put a name for this one, no.
Yes. Last time we saved here only.
Yeah, documents only, sir. In documents only.
First pro. Okay, right. That's right. So it's audio test files. So,
Are you able to hear anything, sir?
mm-hmm. It's audible.
Just change it to 44.1 kilohertz, sir, because we are unable to hear it.
Okay. So sorry. What you see?
Just change the audio sync sample rate to 48 and check the difference, sir. 48 plus, okay.
Yeah, it's more of a shrill sound right now.
Okay. Before it was noisy, sir, in 32 kilohertz.
Yes.
Okay,
Now
sir.
it's
Uh,
yeah, it's working fine.
okay, sir. Now you can in between you can put a low pass filter and filter like this is the frequency I want to receive it. This one I don't want because we don't know like the problem right now, no sir. We don't know the frequency part of this
Wait, yeah,
wave file.
fine. Yes, right.
So if we are able to find it, then we can have a better example of digital signal processing with low pass filter.
But we can just check it out.
Yeah,
Let's
yeah.
sample something.
It's a trial and error only, no sir. No issues.
Right.
Sir, I change the data type, sir.
Yeah. Change.
FIR type.
Let's do
Okay,
float
okay.
resolution.
Cutoff frequency, make it as 500 hertz. I think 2020 like 500. Make it as 500 hertz is fine, sir. 500 is fine. We'll just check because you need to make the difference. Like transition with make it as 10, sir.
We can connect a block and what is transmitting. Can't we see that?
Yeah, I can see it,
Okay,
but
let's
it
do.
won't show the proper parameters. It will be very difficult because it's not a
Yes,
spectrum
multiple
analyzer. No,
things. Right.
sir. Transition with you need to mention 10, sir. Make it as 10 transition. And here one more option is also there. Here, yeah, you can create your own filter also here.
In this filter session, you're saying.
No, here in the tools you can make a filter also. That is also is possible. Run it, sir. Once. What we are hearing, we need to know. Any difference, sir?
No, there's no difference.
Make it 20 hertz, sir. So it need to allow only 20 hertz. Above 20 hertz, it should not allow.
Yes.
No?
Now it's a difference. Yes.
Okay, okay, sir. Okay. Sir,
You were saying we can make our own filter. How we can make our own
sir, go
filter?
to tools because here I don't know. Go to tools. Tools, sir. Tools. File, edit, view, run, tools. Help. Go
Oh,
to
sorry.
tools. Filter design. It will take its sweet time, sir.
They must have some. Okay, we can place the components like we in
Yeah.
MATLAB. Also, we have this specific.
Same way, sir. How many number of tabs are there? If I'm using this much amount of tabs, how much CPU will be utilized?
Mm-hmm.
those kind of parameters you can in 3.8. I'll show you like just stop sharing sir. Share it. To share for 3.8. Sir, in 3.8, there is something separately is there. Python block creation. See, these are for RTL SDR, ACRF, Blade RF. These two are, and this is meant for your USRP, transmission reflection.
I'm not able to visualize there. Okay.
Sir, in 3.7, I'm not sure like where it is there. In 3.8, this is.
Okay, no problem. So in the updated version, we have.
Yeah, we have sir. Something called Python file is there. Sir, see what you can do now. Instead of clicking on the window, click here and press Ctrl F. Python block module. You click on it, this will be open, and you can write your application code here.
Okay.
In description, open editor. So it will open editor. There you can. For that we have written a block. You can check it in our website also. I'll just show you. It is already available in internet, sir.
Okay.
For 3.8 you can do it.
Okay. You're saying at the start everything is very.
Sir, everything. See, that is the thing, sir. Initially I told no. We know the little bit better way to steal something. We have already steal it.
Okay, that's great. Okay, we can module. We can design our module with a practice session. I think with few more practice with ourselves.
Yeah,
we
yes, sir.
get to know this, and then we can design in the
Design,
Python
sir.
or the C++.
Yes, sir. Yes, sir.
Okay.
Sir, right now I'm making it for making you to kickstart. That's it. So
Yes, sir.
you won't make a mistake of this color difference also. So if any red symbol is coming, we can find the error. See, if the color difference is there, I'll just show you, sir. If the color difference is there, what will be the error? See, due to the red symbol is coming. No, see, size A does not match. So if it is size something is coming, then it is the data type. If it is not connected, it will be throwing different error. If the parameters are not mentioned, it will throw a different error. So in that way only we can able to rectify it. Here there are, see, sir, Rajendra sir asked me about bit error rate, but I am having only 3.8. In this error coding technique, they are given some parameter. I am also unable to find what is that.
Actually, that was my next question also. That is it possible to estimate the PER performance of the system?
See, in 3.7, it's already there, sir. In 3.7, hello.
Yes.
In 3.7, it's already there. In 3.8, they have changed it actually. This test mode parameter, they are giving it. Sir, I have given a book to sir actually, Gajendra sir. In that book, bit error rate flow graph is there. But it is, they have used 3.6 and 3.7. In 3.8, they have changed the entire parameter itself.
Okay, so Mr. Pandit, just a quick, I want to know that as we are using USRP, right, we have designed some hardware. Okay, we were processing it using the visible light. So we will transmit a set of signal. For example, a vector in the MATLAB, like I'm sending 10,000 symbols, 10,000 bits, okay? And at the receiver, I'm receiving those bits in some kind, right? And now I want to estimate the BR performance. So with this GNU radio tool, if I transmit some number of bits and connect my hardware in between and at the receiver USRP, the same GUI I can use. So I can use that for the BR estimation.
Sir, could you please repeat, sir? I was confused.
For example, at the transmitter, I'm sending some bits. For example, using this OpenGI you have,
Okay,
okay,
okay.
will design some transmitter. Then I'll
Ah,
connect it to the USRP board.
and it will transmit the information.
It will transmit, and we will receive at the other USRP
Okay,
receiver end.
okay,
Okay.
okay, okay.
Then can I have a information of bit what I have transmitted? For example, 1,000 bits, and at the
Uh-huh.
receiver, can I decode those 1,000 bits what I have actually transmitted?
Yeah, yeah. So see, this is everything is through programming only.
Okay.
See,
So.
which way we are writing the algorithm,
Mhm.
in that way it will work. That is doable. Whatever you are doing with MATLAB, it is doable in because anyway it is coding now. Sir.
Okay, yes. So what this BR, like in the error coding, there is a BR term written, right? So what this BR perform? Yeah, how we can directly use this
See,
box?
in 3.7 they have clearly mentioned this is the parameters we can use it. In 3.8 they are mentioned in this way.
Okay,
So
I'm
when it,
I'm having 3.7. Let me check once, right?
yeah, you can check it. Sir.
Just give me a second. The same way it's presenting. Let me share my screen. Okay. So this is the error coding BR, and
Hmm.
this is what we are getting as a module.
Just a second, sir. Let me show you one. Just just a second.
Should I stop displaying?
Yeah, you can stop sharing. Sir. Just a second. Sir, I'm just checking it, sir. Please be on the line.
Yeah, sure.
Sir, it's visible, sir. Hello.
Sure. Hello.
Visible, sir.
Yes, it's visible.
Sorry, sir. This is the one we used long back. It is available in SAR also, but this block is missing in the newer version of GNA radio. Error, bit error block.
Okay, so it's in the 3.7 version. Is it available,
So it's
or
not
the
in
older one than
older
3.7?
only. It is available, sir. Anyway,
So
I'll just
how?
check it actually. I don't have 3.8 right now. Only I've installed to showcase you. So here the parameters are clearly mentioned for this older version. It's 3.6, I think so, sir. 3.6, I think so, not 3.8.
Is it
3.6 is it.
possible for you to share this link or a file with everyone?
This one, sir.
Yes,
This
because
is,
where it is given about.
sir, this is already there in the book actually. Whatever I've given to sir.
Acha, Mr. Khagan, sir. Okay, we'll
It's
collect.
already there in the book, sir.
Okay.
But I am unable to find this error rate.
Estimation how it is.
That if that is there, like I can able to showcase you directly. There's nothing is there. But I need to check for this bit because in our office also we have only 3.6 or 3.5, I think so. Just for the presentation, I installed 3.8. I was checking for this error rate. Error rate was not there.
Okay, actually, I want to really test it with with this JNU radio and USRP in connection. So the hardware part is also involved. And
Hardware
are
part
we?
I can help you. This I see. What I need to do for you is like I need to explain you what is that parameters are meant for.
Okay.
Then it will be easy for you to proceed further because at next level you can do it. I just need to do the kickstart for you. And
Yes.
I think I've explained it to you how to interface the hardware,
Mm-hmm.
what are the parameters need to be changed. Then
Mm-hmm.
this I can, because error rate is that, then it will be easy for you. Two signals, then just try to compare it and you can get the error rate here directly using this code.
Okay.
Sir, any other doubt, sir?
No, I think from my side.
Sir, Gajendra, sir,
Uh,
Gajendra
just,
sir is not there.
hello. Khagan sir, you are on mute, I think.
I think sir is not there. I think so, sir.
Just me. Just I'll make it.
I'll just ping him, sir. No issues. Sir will be coming, sir.
So, Mr. Patti, if we required your assistant any help during this work, because I will try to do this thing
Mhm.
with our USRP and this GNE radio.
I'll
So,
be that. Anyway, I can get the number from sir. If I'm not attending the call, you can send a mail. Whatever best help I can provide from my end, I can help you.
sure. If you can share your email in the chat box, I will be.
It is with sir. No issues. Just a second. Raghu sir, hope you receive it, sir.
Yes, yes, I have received this.
And if you have any queries, because in a day it will be difficult for me to explain, and it will be difficult for you to understand also. Whatever best I can do it. I have done it, I think so, from my end. If you have any queries, you can mail me. It will take some time for me to also to go through it and reply back to you.
No
I'll just try my
worries.
level best to do it, sir.
Yeah, I'll try with myself. If I stuck in some few things, I'll drop a mail to
Sure. If anything related to hardware, you can ping me at any time, sir. I'll be the
you.
best.
Yeah, or I'll call you by taking Khagin's your
Sure, sure,
contact
sure.
number.
Sir, if sometime if I'm in defense, I can't able to attend the call.
There's
I'll
no
call you
issue.
back
There
later.
is no issue. You can reply whenever you are available.
Okay. Thank you, sir.
Sure.
I think we started with few and we got many. At last, we have only three.
Actually, there was some session after one, so few students must have left here because of it.
Okay, sir. Okay, sir. No issue,
Yeah,
sir.
it's 1:37. The session we have planned for up to one, right?
Oh, sorry, sir. It
Yeah,
got extended. I'm sorry.
yeah, it's okay. So Khaginder sir, I think we have covered lots of thing, and Mr. Pandey is explained everything in a well manner. So we can close if
Uh,
you want.
thanks, Pandi,
Thank you, sir. Thank you
for
so much for your
conducting this
opportunity, sir.
session. I hope that it was useful for our students, and definitely, if required, we can plan a session as per your comfortability and as per the availability of the students.
Sure, sir.
Okay, so
Yeah,
I think we
Khaginder
can
sir, it will be nice if we can have like one or two student in the lab. We will and hardware test actually with the USRP if we can
with
perform
the
this, right?
USRP, right?
Yeah.
So actually, there are some challenges at Pandi's end to basically access the hardware. So, but yes, we will plan. I know
Yeah,
we
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 will
will
will.
plan
plan in
something
future. We
related
can.
to hardware and GNU based, like programming hardware using GNU radio.
Yes,
Yeah,
We
sir.
will,
That is the thing, sir. If today Mr. Rahul was there, so if he have the hardware, so whatever feasible, like it's a guide kind of thing, guidance kind of thing, I can give it to him. So he is having
right.
the hands-on, and
Yes.
that time is also need to be there, no, sir.
Right. Right.
Uh,
no problem. We can plan that session some days
Uh,
after. Right?
uh,
Okay,
yes. Sure.
if everything goes fine, I'll come to Triple 80 and I'll show a demonstration and
that will be great.
Mm,
speak itself.
Yeah.
mm. Okay, then, Pandi, I think we can close this session.
Sure, sir. Thank you,
So,
sir.
are you getting the option to end this recording?
No, I don't have any option, sir.
Okay, so maybe you can leave. I will just stop the recording.
Sure, sure. Thank you, sir. Thank you so much.
Thanks everyone for attending the session, and thanks Pandi
Thank you,
for
sir.
Thank you, Mr.
conducting this.
Pandey.
Sure. Thank you.
Thank you.
Okay, thank you.